Our first question: what is gradient clipping and when is it used? Gradient clipping prevents exploding gradients by limiting their magnitude during training. Think of it like a speed limit for your car. When gradients get too large, we clip them to prevent unstable updates that could crash training. Remember, clip gradients when training RN ends or when loss suddenly spikes. Real example: training language models where gradients can explode from 0.1 to 100 without clipping. Speed limits prevent model training crashes. Our next question: how can you use mixed precision training in Pytorch? Mixed precision uses both 16-bit and 32-bit floating point numbers to speed up training while saving memory. Imagine cooking with different sized pots, small pots for most ingredients to save space, but big pots for delicate items needing precision. This makes cooking faster and uses less kitchen space. Mixed precision can give you 1.5 to 2x speed boost with minimal accuracy loss. Real benefit: training ResNet 50 in 45 minutes instead of 90 minutes with same accuracy. Mixed precision doubles training speed efficiently. Our next question: what are common weight initialization methods? Weight initialization sets starting values for neural network parameters to ensure stable and efficient training. Think of it like tuning a guitar before playing. If strings are too loose or too tight, the music won't sound right. Proper initialization gets your model in tune from the start. Remember, Xavier for sigmoid and tan, Kaming for ReLU activations. Real impact: proper initialization can reduce training time from 100 epochs to 30 epochs. Proper weight initialization accelerates training significantly. Our next question: how do you debug exploding or vanishing gradients? Monitor gradient norms and use techniques like gradient clipping, proper initialization, and batch normalization. It's like checking your car's engine. If RPM is too high or too low, you need to adjust. Gradients should flow smoothly through your network like oil through an engine. Remember, healthy gradients are typically between 0.1 and 10. Real debug: if gradient norm exceeds 100 or falls below 0.001, investigate immediately. Monitor gradients like checking engine health. Our next question: what is model quantization? Quantization reduces model size by converting 32-bit weights to 8-bit or 16-bit representations. Think of it like compressing photos on your phone. You reduce file size while keeping the image recognizable. Quantization makes models 4x smaller and faster, perfect for mobile apps and edge devices. Remember, quantization can reduce model size from 100 megabytes to 25 megabytes. Real use: deploy a 50 megabytes BERT model as 12 megabytes on smartphones with 95% original accuracy. Quantization compresses models for mobile deployment. Our next question: what are TorchScript and JIT in Pytorch? TorchScript converts Pytorch models to optimized representations that run faster and independently of Python. It's like translating a recipe from English to a universal cooking language that any chef can follow. This makes your model portable and faster. Remember, JIT can give 10 to 30% speed improvement in production. Real benefit: inference time drops from 100 milliseconds to 70 milliseconds per prediction on CPU. TorchScript optimizes models for production deployment. Our next question: how do you profile a Pytorch model? Use Pytorch's built-in profiler to identify bottlenecks and optimize model performance. Profiling is like having a fitness tracker for your model. It shows you which parts are working hard and which are lazy. This helps you focus optimization efforts where they matter most. Remember, focus on operations taking more than 10% of total time first. Real insight: discovered that data loading was taking 60% of training time, not the model. Profiling identifies performance bottlenecks for optimization. Our next question: how do you optimize Pytorch code for GPU execution? Use proper data loading, avoid CPU-GPU transfers, and leverage tensor operations for maximum GPU utilization. Think of GPU optimization like organizing an assembly line in a factory. Keep workers busy, minimize downtime from moving materials, and batch operations efficiently. Remember, keep data on GPU, use non-blocking equals true, enable cut-in benchmark. Real speed up. Training time reduced from 8 hours to 2 hours with proper GPU optimization. GPU optimization dramatically reduces training time. Our next question: what is model pruning? Pruning removes unimportant connections or neurons from neural networks to reduce size and computation. It's like trimming a tree. You cut away dead or unnecessary branches to help the tree grow better and use less resources. The tree becomes more efficient while keeping its essential structure. Remember, start with 10 to 30% pruning. You can often maintain 95% accuracy. Real result: pruned ResNet. 18 runs 2x faster with only 1% accuracy drop. Pruning removes unnecessary connections efficiently. Our next question: how can you reduce memory usage in training? Use gradient accumulation, checkpointing, smaller batch sizes, and mixed precision to manage memory efficiently. Managing memory is like packing a suitcase efficiently. Use every inch wisely. Roll clothes, use compression bags, and pack smartly to fit everything you need. Remember, gradient accumulation lets you simulate larger batches with less memory. Real savings: train with effective batch size 128 using only memory for batch size 32. Memory management enables larger effective batches. Our next question: how do you export a Pytorch model for deployment? Save models using TorchSave, convert to TorchScript, or export to ONNX format for cross-platform deployment. Exporting a model is like packaging a gift for shipping. You need the right container and proper wrapping so it arrives safely and works perfectly at its destination. Remember, use state-dict for Pytorch, JIT for production, ONNX for other frameworks. Real deployment: export trained model to ONNX, then run on TensorRT for 3x faster inference. Export models using appropriate format standards. Our next question: what is TorchServe and how is it used? TorchServe is Pytorch's model serving framework that handles model deployment, scaling, and management in production. TorchServe is like having a professional waiter for your model restaurant. It takes orders, serves predictions efficiently, handles multiple tables, and manages the kitchen automatically. Remember, TorchServe handles auto-scaling from 1 to 100 requests per second. Real setup: deploy image classifier that auto-scales from 10 to 1,000 concurrent users seamlessly. TorchServe manages production model serving automatically. Our next question: how do you deploy a Pytorch model to mobile or edge devices? Use Pytorch Mobile to optimize and deploy models on iOS, Android, and edge devices. Deploying to mobile is like fitting a powerful engine into a compact car. You need to optimize for size, speed, and efficiency while maintaining performance. Every byte and millisecond counts. Remember, mobile optimization can reduce model size by 2 to 4x and speed by 2x. Real app: 50 megabytes image classifier becomes 12 megabytes mobile optimized version running at 30 frames per second. Mobile deployment requires size and speed optimization. Our next question: what is ONNX and how does Pytorch support it? ONNX is a universal format for AI models that enables cross-framework compatibility. ONNX is like a universal translator for AI models. It lets a model trained in Pytorch speak fluently with TensorFlow, TensorRT, or any other framework. One model, many platforms. Remember, ONNX lets you run Pytorch models on any platform or cloud service. Real flexibility: train on Pytorch, deploy on Azure ML, AWS SageMaker, or Google Cloud seamlessly. ONNX enables universal model compatibility. Our last question: how do you deploy a Pytorch model using Flask or Fast API? Create REST APIs using Flask or Fast API to serve Pytorch models as web services with HTTP endpoints. Building an API is like opening a drive-through window for your model. Customers can easily order predictions by sending requests, and you serve them quickly through a standardized interface. Remember, Fast API auto-generates docs and is 2 to 3x faster than Flask. Real API: image classifier serves 1,000 predictions per second with automatic load balancing. APIs provide web service interfaces efficiently.